Hello, this is Joel Holder. Today I'm going to give a walkthrough of Python tools for Visual Studio using Visual Studio 2013 and three of my favorite libraries in the Python ecosystem to do some statistical data analysis and some visualization of that data. So just to let you know, there's a few things that you'll need to do as prerequisites. The first thing is that you'll need to install Python. I recommend using the latest Python 3 version available, and in this case it is 3.4.2, running the 64-bit version. You'll need to install Python. It will default to this directory, Python 3.4 on your system. You'll need to ensure that this path and the path to the scripts where we'll find pip, our package management tool, those need to be in the path of Windows so that they can be found by all of the various tools. So just to show you, here's mine, and I do have them at the beginning of my path. Once you've got that in place, clearly, we'll have Python available to us, and we can see that we're running Python 3.4.2, just as what we would have installed there. So with Python in place, then we can use Visual Studio to create a project and go ahead and start playing around with some of these libraries. So we'll create a new project. From the projects, we'll select a basic Python application in this case. And you can see that it stubs out an initial Python file for us with Hello World. I have an interactive Python window already ready for me to use here, and so I can highlight my code and Control-E, which sends it to the REPL, and you can see that it does in fact get executed. Cool. So let's go ahead and dive into some code. I've got what we want to look at already prepared for us here. First thing that we'll do is we'll grab Pandas and NumPy because those are kind of the foundation of what we're going to be working with today. And the first thing we'll do is create a series. Basically a series is just like a vector of values that have an order, and also it supports not a number in cases where you are missing data and have holes, etc. So we can evaluate this code as well in the buffer, and we can see that I have a series now. When I evaluate the series, you can see that I've got an index. Pandas has indexed it for me, starting with 0, and then here's my actual numbers that represent the sequence of type float64. Next, what we'll do is we'll create a range of dates. We're going to use these dates as an index for a data set that we're going to create. So this was really more of just a initial kind of demo. So the dates are going to help us because we want 6 days. And notice the way that the date range method works is that we pass it a date time of precision day, and we're telling it we want 6 periods. Well, it's smart. It infers that we want 6 periods at the precision that we've provided the initial start, and so that's what it's going to provide to us. So by evaluating this code, we can see now that dates gives us a date-time index starting with 1/1/2013 and going through 1/6/2013. Great. So now what we'll do is we'll generate a data frame. A data frame is basically kind of like a data set with an index. And so if you take a look at the code that I've got here, we're basically saying that we're going to create a data frame and assign it to the variable df. It's going to contain a series of, this is an n-dimensional array, okay, of 6 rows by 4 columns. We want that indexed by our range of dates. Notice that there were 6 dates and there are 6 rows, so our rows will be date indexed. And we're also passing in a list of columns, and in this case they will be labeled, the 4 columns specified here will be labeled A, B, C, and D. So when we evaluate this code and the data frame, we see that in fact we do have a data set that looks exactly like we specified. Column A being sampled each day over time, column B, etc. Great. So these data frames are very powerful and interesting little tools. They are easily extensible. So for instance, if I wanted to add an additional column E to my data frame, I have 6 values in this vector. They will be added to the column E for each of the respective rows. So we can verify that that is in fact the case. And now when we evaluate df, you can see that we do have an extra column E, and it has been provided with the values that we gave it. Next we'll go ahead and create a series of dates that are basically indexed by dates, 6 dates, and notice that the dates that we are providing here, earlier we had a range that was started on the 1st of January. Now we're saying started on the 2nd of January, and we want 6 periods, and by the way, here are 6 values. So we create this series, and just to show you, a series is still a series, as you would expect. And we have exactly what you would expect, an indexed series given the vector, or the sequence rather, sorry, that we provided it with. So that's great. So now let's add this sequence to our data set, and we'll add it to column F. So now when we evaluate our data frame, we have yet another column of data that follow the index. What's important to understand with what we just did is that this sequence was already indexed by day, and so when we added this sequence to the data frame, it knew how to line up each of the values based on the index that it already had. So it was able to in effect merge this column in on the index in a very natural and orderly way. So it's important to know that with the ability to create these data sets, we should have also the ability to save these data sets out easily to files, and then work with those files in familiar tools like Excel that will quickly allow us to work with the data in the tools of our choice. Now notice that we had introduced by design not a number value, because the sequence that we built started on January 2nd, so it didn't have a record for January 1st. And so that shows up in Excel as basically a hole in our data as we would expect. Now let's just say for the record that we wanted that to be 88, and we'll save this file and go ahead and close it now. And back in our REPL, we can read that file back in, and we can show you that we have a data. We've just created a data frame by reading that Excel sheet back in, and we've sort of round-tripped our data frame out to Excel and brought it back in. This is a very powerful capability that I really liked because it's very convenient. So the data frames are searchable, and I'm not going to go through that right now because I think what's more important is let's visualize some of this data. So I've got a couple of series here, and I'm creating. I'm going to go ahead and create these. Put this code up here to show it to you. So we've got another series, and basically in this case we're saying that we want 1,000 data points, and we want an index range of dates, and we're saying start on the January 1st of 2000 and give us 1,000 periods, and since this is of day precision, this will give us 1,000 days. And we'll then take the, just to generate some shape in this data, we'll take the cumulative sum, and then we'll plot it. Okay, and so we're going to do this for our data here, and send it to the REPL. And so now we want to show this data. We want to just see what it actually looks like. And so to be able to do this, we're going to need to pull in a few more libraries, and we can get what we need here, PyPlot, just by pulling it in, and then this will allow us to basically show the plots that we're creating, so that we'll be able to visualize our data in a very natural way. So we can, down here in the REPL, I can just simply use the plot object. Notice that we have IntelliSense, by the way. I didn't point that out earlier, but I'm going to run the show method, and we see that, oh, I forgot I ran it 3 times. Yeah, so I've got actually three series here that are plotted. I ran this one time, and then I ran it again with a total of 3 times. Notice that that is the way that it works, is that you can basically, and I'll go ahead and put our plot show in here, and we'll run this code. And so I ran it one plot, and I have one data stream. If I do this twice, I'm going to get what you would expect. 2 different random data series plotted. So this is a way that you can very quickly visualize your data, and you can save these graphics that you generate quickly out to files. You can also save them directly from code, and the important thing to realize at this point is that if you can generate graphics so easily using these data frame objects and PyPlot, then sucking data sets in from Excel and from CSV and from JSON APIs can really give you feeds of data that you can quickly plot and turn into visualized data that can help us really see what's going on within the data itself. So that's just a taste of this tooling. By the way, I did say that we could debug this stuff, so I figure we might as well do some of that stuff. Let me put a breakpoint here, and we'll go ahead and fire up the debugger. Python's got to bootstrap and get us going, and here we are. We've hit our breakpoint. We can have additional breakpoints here, for instance, that we can move through. Now that the dates object has been instantiated, I have the full set of IntelliSense that you typically expect. We can create watches on our objects and see that this is a date-time index, just as it told us that it was in the REPL. And these are pretty great features because we can work with Visual Studio in a way that we're used to working with it, stepping through the code, even to the point that we want to, while we're in a debug session, play with our Python code in a REPL. What we can do is open the Python REPL, if I can find it, the debugging REPL. Where is that thing? There it is. I need to learn that keystroke. Shift Alt I. Okay. Yeah. So basically, we can also have a interactive REPL for our code while we're debugging it. So, as you would expect, we can evaluate our time series and it truncates it. It didn't put all 1,000 of them here, just for the sheer sake that it didn't want to do that. But clearly the object is there, and if we wanted to print it, in fact, I think that's a worthwhile endeavor, perhaps. We get the full 1,000. No, we don't. Okay. In any case, this is your basic, and as you would expect, you can change objects. And so for instance, you can see that in this code we're going to run two plots, two different series through the plot method twice, so we would have 2 data points show. I am going to, while I have the REPL open, run these methods a few more times, so that now when we let it complete and show us the chart, we have several more plotted series on our chart because I added those at runtime from the REPL. So it's really pretty slick the way that these tools interop. It's a great development experience, and just so you know, you can add your Python environment into Visual Studio, and you can see all of the modules that I have here. Once you've done this, you can actually install Python packages using pip directly from within Visual Studio, which really gives you that final feature you need for package management inside the IDE. So that's it, and hopefully we got something out of this. If anyone needs help or would like to discuss this in any way, feel free to email me. Thanks, and have a great day.